D, B, E, and C are points on a circle centre O. A, B, E, F, C is a straight line. ADO is a straight line, and EFO is a straight line. And also we're told that AD is 4, BF is 4 centimetres, FC is 7 centimetres, and EF is 2, and that AB is equal to X, and we've got to calculate the value of X. So taking our diagram, what we need to do is calculate the radius of the circle. Now to do this, we're going to extend this line EFO, this line here. We're going to call this point here G. So this distance here is the radius, so we'll call that R. So this distance from here to here is also the radius, but we know that this distance here is 2, so the distance FO will be R minus 2. Right, now we're going to use the intersecting chords theorem with the intersection inside the circle. So what we're going to do, we're going to consider this chord here and this chord here. So we're going to say that GF, G to F, times E to F is going to be equal to B to F times C to F. So F is the point where the two chords intersect. So G to F is going to be R plus R minus 2. E to F is going to be equal to 2. And then B to F is equal to 4. And then F to C is going to be equal to, well, C to F is going to be equal to 7 centimetres. So this gives me 28. And then R plus R minus 2 gives me 2R minus 2. Times 2 is equal to 28. If we divide both sides by 2, we're going to get that 2R minus 2 is equal to 14. If we now add 2 to both sides, we get 2R is equal to 16. Divide by 2, we're going to get that R is 8 centimetres. So we now have the radius of the circle, which is 8 centimetres. Right, taking our dot diagram again, this time we're going to extend the line ADO. So extending the line ADO, and make this point H. Now we know that this distance here is the radius of the circle, which we now know to be 8 centimetres, and also that this length here, DO, is also the radius of the circle, which is 8 centimetres. So now using intersecting chords, but this time they're intersecting outside the circle at A. So we're going to have AD times AH is going to be equal to AB times AC. So AD is 4 times 8 plus 8 plus 4. So don't forget that A to H is going to be 4 plus 8 plus 8. And that's going to be equal to ABX, which we're trying to find. And then AC will be X plus 4 plus 7. Okay, so we're going to have 4 plus 8 plus 8. So it's going to be 4 times 20 is equal to X times X plus 11. 4 plus 7 is 11. 4 times 20 is 80. And then if we expand the bracket here, we're going to get X squared minus 11X. Quadratic, so to find the solution of that, we're going to put it equal to 0. So we're going to have x squared plus 11x minus 80 is equal to 0. Now you can either solve this using the quadratic formula, but it does actually factorise. The product will be 1 times minus 80, which is minus 80. The sum is 11. We want two numbers. When we multiply them together, we get minus 80. And then when we add the same two numbers, we get 11. With a bit of trial and improvement, you'll come up with minus 5 and 16. Minus 5 times 16 makes minus 80. Minus 5 plus 16 makes 11. So we're going to have that 0 is equal to x squared. So you split the 11x up into minus 5x plus 16x minus 80. You group the first two terms together here. So you're going to have x times x minus 5. And then here you take out a common factor of 16. Bring down that plus sign, and then you're going to have x minus 5. If you do this correctly here and here, you always have the same thing. Factorizing out, we're going to have x minus 5 times x plus 16. So either x minus 5 is equal to 0, which means x is equal to 5, so that's okay. Or x plus 16 is equal to 0 and x is equal to minus 16. That's not possible. We can't have a negative length in this situation. So therefore there's just one answer, which is this one here, that x is equal to 5 centimeters. So this has been a video to show you how to use intersecting chords both inside and outside the circle. I hope you've understood, and I thank you very much for watching.